Hi everyone, welcome back to the channel. So today we are going to discuss one of the most important and most interesting topic in operating system, that is introduction to deadlock. So along with the introduction, we will also cover 4 necessary conditions for deadlock, and this video is very helpful for all the students who are preparing for their college or university level examination, as well as if you all are preparing for any competitive exam. This video will definitely help you. So let's start with the introduction part. So students, deadlock is nothing but it is an unwanted situation in any operating system where the processes and the resources got stuck in such a manner that it becomes very difficult sometimes to release all of them from this unwanted situation. Okay, so let's take an example here. Let's take an example that we have 3 processes P1, P2 and P3. All these processes want CPU, that is a common resource, at the same time. Let's let's take here that P1 process is using the CPU at particular time. P2 process is waiting for the CPU to released by P1, and process P3 is also waiting for the same resource. At this particular time, only when P1 process releases the CPU, only then it will be allotted to process P2. If P1 does not release the CPU for a longer period of time, then it becomes a deadlock. Deadlock is an infinite waiting. As I have told you, if P1 is not going to release the CPU, let's say for 3 days, okay, so for 3 days, process P2 have to wait. So this is the infinite waiting, or we can say it is the long waiting. Sometimes in case of operating system, the long waiting or infinite waiting is also known as starvation. Okay, so because of deadlock, our operating system or our system may enter in the starvation situation. Okay, let's take one more simple example here. Deadlock is an undesirable state of a system, and it occurs when set of processes, we have 3 processes, right? It occurs when set of processes are in waiting state. Deadlock is a situation where no process got blocked and no process proceeds, and it is infinite waiting. Let's take an example here again. We have 2 processes. Process P1 is using resource R1 here right now. Okay, and it is also waiting for resource R2. But the resource R2 is currently occupied by process P2, that is also waiting for process P1. So here it becomes a cycle. So remember one statement: whenever there becomes any kind of cycle in your operating system, that means your process is going to be entered in deadlock situation. All right. And in case of any operating system, we have 4 necessary conditions for deadlocks. In simple terms, we can say that ये 4 condition हुई तो deadlock हो सकता है. But if we are able to control any of the situation, any of the necessary condition, that means with the help of controlling any situation, we will be able to control the deadlock. इनमें से किसी भी एक सिचुएशन को, किसी भी एक कंडीशन को अगर हमने कंट्रोल कर लिया, इसका मतलब है कि हम इजीली डेडलॉक को भी कंट्रोल कर सकते हैं. ओके, वन मोर पॉइंट आई वुड लाइक टू ऐड हियर इज, we have 2 terms in case of deadlock. First is unsafe state and another is safe state. Okay, so let's draw it like this. We have 2 situations. First is safe state and second is unsafe state. Remember one point, The deadlock is always a part of unsafe state. Whenever we talk about safe state, that means there will be no deadlock in our system at any cost. Okay, and whenever we talk about unsafe state, that means there is a probability of having a deadlock. Remember one point, deadlock is a part of unsafe state. That does not mean कि every unsafe state leads to deadlock. Every unsafe state does not leads to deadlock, but every deadlock is a part of unsafe state. This particular statement is very important. In every competitive exam ये statement में से question आते ही है. Okay, so now we have four necessary conditions, where the first condition says mutual exclusion. Mutual exclusion, in simple terms we can say it as non-shareable. Non-shareable situation. That means only one process can use a resource at any given time. That is, resource is non-shareable here. Let's take an example. We have again three processes and a common resource CPU. Okay, only one process at a time can use a resource. Process P2 and P3 are not allowed to use the CPU at the same time when P1 is using this. That is called mutual exclusion. Okay, second statement says hold and wait. As we have already discussed here, hold and wait, that means process P1 is holding resource R1 assigned to लिखा है. That means process P1 is holding resource R1 and waiting for resource R2. That is hold and wait. Holding something and waiting for something else. Process P1. Let's take some real life examples. Person A is using my laptop right now. Okay, and at the same time person A is holding my mobile too. That is the hold and wait situation. And I am person B. I am waiting for person A. I am waiting for this child A to release my mobile as well as to release my laptop so that I can work. So this is the hold and wait situation. A process is holding at least one resource at a time, and it is waiting to acquire other resources held by some other processes. Right? This is hold and wait. Third type is no preemption. In CPU scheduling, we have already discussed preemptive and non-preemptive algorithm. So this is non-preemption. Non-preemption means non-stoppable. Okay, and preemption means stoppable. In case of non-preemption, when a resource is in case of non-preemption or non-stoppable, whenever a resource is allotted to any process, we cannot release the resource until the process fulfills its requirements. Let's take an example here. Process P1, P2 and P3. Process P1 wants CPU for 10 minutes. Process P2 wants CPU just for 1 minute. And P3 wants CPU for 3 minutes. Okay, so at first process P1 is using CPU, right? Process P1 is CPU, and here process P2 is saying to CPU that I want CPU just for 1 minute. It is the shortest time. I want it just for 1 minute. But in case of non-preemption means non-stoppable, that means the process P1 जब तक अपनी रिक्वायरमेंट को फुलफिल नहीं कर लेता वो सीपीयू को रिलीज नहीं करेगा, राइट? चाहे उसको 10 मिनट लगने हो, चाहे 40 मिनट लगने हो, जब तक उसकी रिक्वायरमेंट पूरी नहीं होती वी कैन नॉट स्टॉप द प्रोसेसिंग। ओनली आफ्टर 40 minutes it is it will be serviced to the process P2, right? This is non-preemption. The resources can be released by a process voluntary, that is after execution of a process. Fourth point is circular wait. Circular wait we have discussed. This is the circular wait. Okay, cycle is created here, and whenever in any operating system, whenever a cycle is created, that means it is the possibility of having a deadlock. Okay, so I hope students everything is clear till now. So in next video we will be discussing deadlock avoidance, that is Banker's algorithm, as well as deadlock prevention techniques that are very important. So thank you so much.